NENOMATICA, where mathematics meets YouTube excellence. We will place the problem statement exactly in bold orange math. Step 1. Identify the case based on K. We start by recalling the floor equation form. This single equation has two unknowns, x and y, so typically there are infinitely many solutions. We split our analysis into two paths, when k equals 0 and when k is not 0. Step 2. Choose an integer value for one floor term. We will use the arbitrary selection rule. Let us pick the floor of b, y to equal 2 as a concrete example. Substituting into the k not equal 0 case gives the floor of ax equals k minus 2. Step 3. Solve the inequalities for y using the definition of the floor function. We recall that the floor of u equals n if and only if n is less than or equal to u, and u is less than n plus 1. Because the floor of by equals 2, we must have 2 less than or equal to by, and by less than 3. Now divide by b, paying attention to the sign of b. Step 4. Solve the inequalities for x using the expression for the floor of ax. Since the floor of ax equals k minus 2, the value of ax must lie between k minus 2 and k minus 1. We divide by a, again considering the sign of a. To capture all solutions, repeat the same steps for any integer n. Set the floor of by equal to n, then the floor of ax equals k minus n. Convert each floor equality to an interval using the floor definition to get the full family of solution intervals. Therefore, the complete solution set is the union of all such intervals for x and y over every integer choice of n. That is the full algorithm for solving the equation with floor brackets. Quick summary. We identified the case by looking at k, chose an integer for the floor of by, converted floor equalities into intervals, and then repeated for all integers n. In this example, we will solve the equation. Floor of x plus floor of 2x, all inside a floor, equals 9. We will decompose x into its integer and fractional parts, analyze floor of 2p, and finish with interval notation for the solution set. Step 1. Decompose x as n plus p, where n equals floor of x, an integer, and p is the fractional part with 0 less than or equal to p less than 1. Then floor of n plus p equals n. Next compute 2x, which is 2n plus 2p. Since 2p lies between 0 and 2, floor of 2p is either 0 or 1. Therefore, floor of 2x equals 2n plus floor of 2p. Step 2. Use the rule floor of a plus k equals floor of a plus k when k is an integer. Here, floor of 2x is an integer. So floor of x plus floor of 2x equals 9. Substituting our expressions gives n plus 2 n plus floor of 2p equals 9. That is 3n plus floor of 2p equals 9. Step 3. We perform a case analysis on floor of 2p. Case 1, floor of 2p equals 0. Then 3n equals 9, so n equals 3. The condition floor of 2p equals 0 means 0 less than or equal to 2p less than 1, hence 0 less than or equal to p less than 1/2, with n equals 3. Step 4. Case 2, floor of 2p equals 1. Then 3n plus 1 equals 9, so 3n equals 8, which makes n equal 8/3, not an integer. Therefore, this case gives no solutions. Step 5. Final answer. The complete solution set comes from case 1 only. Therefore, x lies in the interval from 3 to 7/2, including 3, but excluding 7/2. As a quick check, picking x equals 3.25 gives floor of 3.25 plus floor of 6.5 equals floor of 9.75, which is 9. This matches our solution interval. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.